So in the previous video, went through the 3 different cases. So now let's use some practice. So the first thing you always want to check is if the center is on the line. So let's apply these 3 cases to these 2 regions questions. A line segment is dilated by a scale factor of 2, centered at a point not on the line segment. So when it is not on the line segment, we are going to be creating a brand new segment. Which statement regarding the relationship between the given line segment and its image are true? So if we look at our previous drawings, right, our options were that it was either going to be the same line or that the lines were going to be parallel, depending on where the center was. So I can immediately go through and eliminate anything that's talking about perpendicular. So now the line segments are parallel and the image is twice the length, or the images are parallel and the image is 1/2. Well, if my scale factor is 2, I would be multiplying the distance by 2. So my distance is going to be twice my original. For the next one, a line is dilated by a scale factor of 1/3 centered at a point on the line. Which statement is correct about the image of the line? So if the center is the point on the line, nothing changes. The image of the line and the pre-image are the same image. That is a tricky thing if you do not remember the 3 different cases. If the point is on the line remains the same. Anything else is going to be a parallel separate line. But you need to know that if the center of the dilation is on the line, it is going to be the same line. So now we have to look at the next one. It's a U-try. We're given the equation of the line y equals 3x minus 1 is transformed by a dilation with a scale factor of 2 and centered at 3, 8. The line's image is. So you could graph it. The first thing I want to do is I want to see, is this point on my line? And this is how you test it. So your equation is y equals 3x minus 1. If you're looking at your coordinate points, we have 3 and 8. 3 is your x value, and 8 is your y value. If this point is on the line, it will make this equation true. So we have to say, is 8 equal to 3 times 3 minus 1? And lo and behold, they are equal. So this is a point on the line. You could have also graphed it as well if you wanted to check. So because it is a point on the line, the equation does not change. The center is on the line, so the pre-image and image are the same. So now for some more practice. On the graph below, point A, 3, 4, and BC with coordinates B, 4, 3, and C, 2, 1 are graphed. What are the coordinates of B' and C' after BC undergoes a dilation centered at point A with a scale factor of 2? So we're increasing our original distances from A to each of these points by 2. So if I look, my original distance from A to B is 1 right, 1 down. So my new distance will be 2 right, 2 down to create B'. So B' is going to be located at 1, 2, 3, 4, at 5, 2. So I can eliminate anything that does not have B' at 5, 2. And now I'll do the same thing for C. So to get from A to C, I went to the left 1, down 3, 1, 2, 3. So now I'm going to go to the left 2 and down 6. 1, 2, 3, 4, 5, 6 to get C prime. So this would be your new segment. C prime would be at 1, negative 2. So your answer will be 1. The line 3y equals negative 2x plus 8 is transformed by a dilation centered at the origin. Which linear equation could be its image? Well, the first thing you want to check is the origin on this line? So let's say 3 times 0 is equal to negative 2 times 0 plus 8. And that would give me 0 is equal to 8. So it's not on the line, so it's not going to be the same. So we know that the lines have to be parallel. So if I rewrite my equation, so my original equation was 3y equals negative 2x plus 8. If I move this guy over, right, if I add it to the other side, I now have something that is very similar to what is currently being written up here. The slope has to be the same. So the coefficients, the numbers in front of x and y, have to be the same. So I can eliminate 2 and 3 and 4 right away because there's a minus. And now I'm looking 2x plus 3y. So this is going to be my answer, because if you convert it to slope-intercept form, the only thing that will be different about these two will be your intercept, not your slope. And remember, when you dilate a line, the resulting image has to be parallel. The coordinates of the endpoints A, B are A, 2, 3, that should be a 3, and B, 5, negative 1. Determine the length of A prime, B prime, the image of AB after a dilation of 2. And we'll say this is centered at the origin. So we're starting at 2, 3, and B is at 5, negative 1. And let's dilate this by the origin. So if you're dilating by the origin, all you would really have to do is multiply everything by the scale factor. So 2, 6 will be 2, 3 will become 4, 6. It's 1, 2, 3, 4, 6. And B will become 10, 10, negative 2. Oh, determine the length of A prime, B prime. So this is actually even easier. So you just have to double your original length. So if we look, we're going over 3, 1, 2, 3, 4. So this was a distance of 5, because you would use the distance formula, but I just know this off the top of my head. So double the distance for 10. This is why you have to read. So given the 2 points, first find the slope. So difference of y over distance in x, which gives me 1/3. Slope of a line parallel is 1/3. Perpendicular, negative reciprocal, which simplifies to